Okie dokie. So in this video we were looking at reading the graph of the first derivative. So we are given a first derivative graph. So I need you to press pause and take a moment and copy down this sketch of the graph. Make sure you mark down these key points that I've highlighted and make sure you draw it going from -4 to +4. Okay, doesn't go beyond that. And also make sure you jot down these 4 questions. Alright, so first question, we're looking to find the intervals where f is increasing. Well, f is increasing where f prime is greater than 0. So on our f prime graph, we're talking about where it is above the x-axis. Well, the intervals where it's above the x-axis would be from -4, we're including that -4, to -2, but not including -2 since it's right on the x-axis, where the derivative is equal to 0, and then again from -2 to +1, that would be another interval, okay, where our first derivative is greater than 0. Now, sometimes you will see multiple choice questions where they group these two subintervals together and say -4 to +1, including all of those values, okay? It's the idea that at -2, sometimes that's called a shelf point. Think of it as it's resting for a moment, okay? But on each side of it, it is increasing. So we can just say that it's increasing over the entire interval. So sometimes you might see it like this. Other times you'll see it like that, okay? Next question, we want to find the intervals where f is concave up. Well, f is concave up when the second derivative is greater than 0. So keep in mind that this is a graph of the first derivative. Don't make the classic rookie mistake of assuming that this is a graph of just f. In other words, you can't say, well, okay, right here it's bent upward, right here it's bent downward, right here it's bent upward, right? That's only if you're given a graph of f. This is a graph of f prime. So instead, what you need to do is to get the second derivative, we need to take the derivative of the first derivative. So we're looking for where the second derivative is positive. So that means we're looking for where we have positive tangent line slopes. You can see that happens between x values from -2 to 0, not including those, because at -2 and 0, you're looking at a low and a high point, so the slope would be 0 there. And then again from 3 to 4, that's where we would have a positive tangent line slope, so that means the second derivative would be greater than 0. Okay, our next one, we're looking to find x-coordinates of our local extrema. Well, let's start with local max points. Okay, again, this is a graph of f prime, not f. So it's very tempting to go around and be like, okay, there's a local max, here's a local min, here's a local max, here's a local min, right? It's not that simple, right? This is a graph of f prime, not f. So if we're going to have a local max, f prime needs to go from positive to negative. Well, we're going to have a local max at x equals 1. Okay, look at to the left of 1. F prime is positive. And then look at to the right of 1. F prime is negative. So when our first derivative goes from positive to negative, we have a local max. Alright, now let's talk about local min values. It's very tempting to think that at -2 you have a local min, but notice that your sign is not changing. Alright, to the left and right of that point, f prime is positive. So it continues to increase. Okay, so we do not have a local max at -2, or a local min rather. We actually will have a local min at x equals -4 and at x equals +4, so at our endpoints. And let's understand why. So let's first look over near -4. Okay, just past -4 here, All right, we know that our first derivative is positive. Since the first derivative is positive, we know that f is increasing. So if you think about your f, okay, if f is increasing, all right, it's going up like this, so at -4 you must have a local min. Likewise over here at +4, if we were to look at this portion of the graph just to the left of +4, we said that the first derivative is negative since it's below, so that tells us that f is decreasing. So if we were to just focus in on just a little portion of our graph of f, if it is decreasing as it comes to +4, it must mean that it's another local min. Okay? So paying attention to the fact that f is either increasing or decreasing as you get close to those endpoints, that tells you if it's a local min or max. Okay? All right, and finally we're looking to find the x-coordinates of our inflection points. And by the way, we're talking about on f. So please go back up here to number 3. This is referring to on f as well. Okay? I mentioned it with 1 and 2, but forgot to with 3 and 4. So our inflection points. Well, this is where the second derivative is equal to 0 and the second derivative changes sign. Well, given the first derivative, the second derivative is the derivative of the derivative. So where is that equal to 0? Well, that's going to happen where we have tangent line slopes of 0. Okay, so that's going to be these high and low points on this f prime graph. Okay, so that's going to occur when x equals -2, when x equals 0, and when x equals 3. Notice that your second derivative signs are changing on each side of these values. Right? Your slopes are going from here negative to positive, up here positive to negative, and then negative to positive. So our second derivative is changing signs on each side of those points, and for each of these points the second derivative was equal to 0. So they are inflection points.